Hello, welcome to Majestic School. Today we are going to talk about the Pythagoras Theorem. The Pythagoras Theorem. Usually, the Pythagoras Theorem is applied in a right angle triangle. In a right angle triangle. Let us take this as our right angle triangle. Let's take this as the right angle point where you have the 90 degrees. This point is always 90 degrees in angle. This line that is the longest line is called the hypotenuse, and this line is called the adjacent, and this line is called the opposite. Let us call this point our point A, and this point our point B, and this point our point C. The hypotenuse side, let us represent it as our H, hypotenuse side. Let us call this opposite side as our O, or let's call this hypo, OPP, opposite side. Adjacent side, let us call it ADJ, okay? Hypotenuse side is always the longest side. The opposite side is usually opposite this angle here that is very on the same base with the 90 degrees, the right angle point. So it's always on the same base. Whatever way you turn the shape, it will always be on the same side by side by the 90 degrees. That is the angle that creates the opposite. It's always facing this line AC, line AC. From here to here is line AC. So this is the angle that creates this opposite. That is why it is called the opposite. This is the hypotenuse side. It's called the hypotenuse side because it is the longest side. Then you have this one that is adjacent. It's called the adjacent because it's just adjacent to this. It's nearby the side of this 90 degree. It's called the adjacent because it is nearby this side, usually on the right hand side of it. All right. Okay, sometimes it can be on this side. Doesn't really matter, but it's just by the side of that 90 degrees. In naming, in geometry, when we are naming sides of angle, sometimes we can decide to name the side by the points that are opposite in capital letters. Let's assume this one is B, this one is C, capital letter B, capital letter A, capital letter C, capital letter A, capital letter B, capital letter C. So if we want to also name this hypotenuse side or call this hypotenuse side or represent it in any way, we can say it is small letter A because the small letter A is opposite this point, it's opposite this point, capital letter A. Then we can call this line, small letter B. We can also call this line here, small letter C. So in another way, we can redraw it again. We can redraw our right angle triangle. We can redraw our right angle triangle. This is our, and say this is our A, and and this is our B, and this is our C. So just because it's the side, remember this place, the point is capital letter A. The point here is capital letter B. The point here is capital letter C. But the side here is small letter b because it is opposite this point. The side from here to here is small letter b. So we can say in this place, side AC is equal to small letter b. Side AB is equal to small letter c. Side BC is equal to small letter a. Can you see now? So the points represent the capital letters and the sides represent the small letter, or the small letter represent the side. So here, now about Pythagoras theorem. Pythagoras theorem is simply saying that the square on this side, on the hypotenuse side, let us assume that this from this point to this point creates a side of a square. In one of our videos, I've treated squares. I've taught about squares. So please go to that video. The link is there. Go to that video and watch it. You see, we talk about square very well. So let's assume this is a square. If you are to find the area of this square, so we call this place, since all the lengths are equal, it's a square, all the lengths are equal on the hypotenuse side, so we say this is a square, a square. All the lengths here are equal. If we assume all the lengths are equal, this is C square. All the breadth here, all the lengths are also equal. This is also a square, B square. So the Pythagoras theorem is saying that the square on the hypotenuse side, remember we call this one the hypotenuse side, the square on the hypotenuse side is equal to the sum, when you add this together, to the sum of the squares on the other sides. The square on the hypotenuse side is equal to the sum of the squares on the other sides. So that is why we have a square is equal to b square plus c square. A square is equal to b square plus c square. And if we want to do a simple calculation, let's assume we want to find the distance between point C and A. So we simply say, if we want to find the distance between point C and A, we simply say A square is equal to b square plus c square. Let us assume we are finding the length a square. So let's assume b is 5 cm, then c is okay, let's also assume it's 4 cm, so it will be 4 cm, and c is 3 cm. Okay, good. 4 cm, 3 cm. And if we have a shape like that, where we can solve this easily, we say a square is equal to 4 times 4, that is 4 times 4, that is square, 4 square, plus 3 times 3, and we have a square is equal to 16 plus 9. So a square is equal to 25. So if we want a alone, a is equal to the square root of 25. So a is equal to 5. There are 5 centimeters, 5 meters, whichever one that is most conducive. This is one of the ways to find distances of points. You can also find the distance between A, B, distance from point A and B, the distance between point A and B, the distance between point A and C. You can find distances this way. This is one of the ways to use to find distances. More videos will be done on how to find distances in the future. We have a video also on coordinates, finding points of coordinates. You should check on that video. It will also help you to find distances as well, how to find points and position. Thank you very much. Please subscribe to this channel, share this channel, like this channel, make comments, say something that will help us to improve. Write to us and send us messages and share with your friends so we can improve in whatever we are doing, so we can do more videos like this. It's painstaking to do videos like this. Encourage us by giving us a thumb up and saying good things. Share it and subscribe. Thank you very much. Thank you very much. Goodbye.